So today we'll be covering masonry. Now typically when we think of masonry, we think of hard materials like you go out and you buy a masonry drill bit. It's a drill bit with a very strong section on the front of that drill bit for drilling into stone or brick or something like that. The actual term masonry refers to the construction of something whereby you have individual units held together with a mortar gap. So technically I could grab lumps of dirt and put mortar on them and join that together. That's masonry, or plastic bottles or something. So masonry actually, as a definition, relates to individual units bonded together. Some terminology around that. All of our horizontal joints, it's very easy to see with our brickwork. These are our bed joints because they provide the bedding. So all the mortar that goes underneath the bricks, they are our bedding. All the mortar joints in between the bricks, they're our perpends because they're perpendicular to the bedding joints. With stonework, I guess essentially it gets a little bit of a grey area. Some of those are they bed joints or perpends, particularly when you're at these sort of sectors, etc. So it's very clear and easy to see with our brickwork. So the important thing to take away, what I consider to be very important from this lesson, something I've applied a lot, is this: the standard size of a clay brick. So 110, 230, 76. It has a huge influence, as I said earlier, on the way that we build. Impacts on sizes of other building elements. But it's also incredibly handy for anybody doing estimating, also for being able to go, work out volumes, go, okay, we're 15 bricks high by whatever. It's incredibly handy tool to have. So remember that. Now that's the size of the brick, and when we think about the size of the brick, if we're going to be calculating wall heights and things like that, we always add 10 millimeters to our dimension. So for our height of 76, we'll add 10 millimeter mortar gap to that. So every brick provides an increment of 86 millimeters to our height. Of course, not all mortar gaps are going to be exactly 10 millimeters, but as an approximation, that's what we arrive at, and that's what bricklayers lay their bricks to be. Is somewhere close, approximating 10 millimeters. So, but it's not just clay bricks that we deal with. Other types of bricks, concrete bricks and blocks, natural stone, autoclaved aerated concrete. Now, is everybody familiar with autoclaved aerated concrete? Yeah. I'll pass around because for something that looks quite rigid, it's surprisingly light, isn't it? Yeah. You go to grab it and yeah. You're able to pass that over. Oh, yeah.
Wow.
Yeah. Well, here. Compare that with a piece of limestone. It looks basically the same. Yeah.
So just contrast. This
Cheers, thank you. Yeah. So in this form, so typically it's called Hebel. Like CSR Hebel are the manufacturers of this. It's produced by, maybe the slides cover it, so I won't go too much into detail, but it's produced by having a cement slurry and then adding, I think it's aluminium oxide to it, and that aluminium oxide reacts with something or other in either the cement or the water or something to produce gas bubbles, and it foams the cement mixture up, and then it's baked into place. So you get all the air bubbles trapped inside there. So it still has that structure of, we won't say concrete because it doesn't have any aggregate in it, but that, yeah. Well, I guess what it is, it's autoclave area concrete. Yes, I can call it concrete. So it has the properties of concrete with a lot of air added to it. Calcium silicate bricks is not something we use in SA because we've got lots of reserves of clay for making our bricks. Glass fibre reinforced plaster, no, not really, and plastic bricks, no. A few, we've got glass blocks down there on that bottom pile, so some glass blocks get used about the place as well, but they're not quite in vogue at the moment. Also, things such as natural stone, typically we still use that in construction, but typically only as a veneer. So stone is cut in very thin and it's stuck on the outside of probably a substrate like a brick wall. Possibly I have some sawn stone in here as well. Oh, that's a fairly thin one, so that's a bit more authentic looking. I'll pass that one around. So it's that sawn. Is that? Yeah, Mount Gambier limestone. So actually, while we're looking at the Mount Gambier limestone, so that's a sawn section, and you stick those sections on to a solid wall to give that stone look. But here, this is part of a floor tile. It's not a good example, but typically a lot of I guess probably a lot of you would have seen the stone veneer that you can buy about the place in panels. It looks like stacked stone. There's all these there's all just little bits of stone stuck onto something which get stuck onto the wall. So that's typically our use of stone within buildings. But that Mount Gambier limestone, I actually like that myself. I think it's a good thing, and because they can actually create those blocks and create quite large blocks just by sawing limestone out of the ground. So you get a very neat finish, and it's very carbon or low carbon intensity, so because they're not having to fire it, etc. So I particularly like the product, but because we have to include insulation within our walls, it gets harder and harder to incorporate the use of stone within our walls, because we can't do just solid stone walls as an external wall, because then we don't get, like in a climate zone 5, we have to have R1.5 insulation in the external wall. So there are issues with doing that, but also in laying stone as well. It's quite expensive and labour intensive. So, properties of clay bricks. So tests are carried out on bricks to ensure that the limits set for dimensions, tolerances, efflorescence, transverse strength and compressive strength are adhered to. Tests are also conducted for characteristic expansion, initial rate of absorption of water and absorption properties. So we want to have dimensional tolerances or dimensional standards to ensure that if the drafter or designer goes to all the work of doing their brickwork dimensioning, that when the bricklayer goes to lay all those bricks are going to line up with dimensioning as was expected. So it is important that the brick manufacturers continuously monitor their bricks and how they come out and how they relate to those dimensions. Well, there's something there mentioned as efflorescence. Has anybody seen efflorescence or know what it is? What could explain that? You got a slightly puzzled.
Is it the line of like?
I think
Is it a line left after the moisture's evaporated type thing? Or?
Yeah. Typically you see it on concrete, but you see it on bricks as well, to an extent. So yeah, it's this line of, sometimes it can, in its extreme form, it can be quite powdery and flake off. Like you run your thumb along it and you'll get a whole lot of white powder, or on your fingers or so. Typically you see it in carport slabs, because you've got a bit of weather that comes in, soaks into the concrete and then dries out, and you get these lines of dissolved salts. Basically that's what it is, dissolved salts with a few other minerals in it. That's what efflorescence is. it's not a real issue in and of itself, and it's not indicative of a major issue. It's just more an aesthetic thing. So with any product which is made from stuff that comes out of the ground, there are dissolved salts in there. So this was, you know, a heap of clay that was dug out, formed into a brick shape, and then baked. There are going to be dissolved salts in that. Now, if that is relatively, or if that's porous enough for moisture to get into and grab a hold of those salts and bring them out, then you'll get efflorescence on the brickwork. Yeah, unfortunately, you know, I can't show any examples of that on bricks that we've got because they're not in place. They're not getting wet. Transverse strength and compressive strength. So they want to ensure that the bricks are going to be strong in a lateral sense, but also strong in a load-bearing sense. So compressive force, the pushing together from gravity of imposed loads on the bricks. Characteristic expansion. Bricks work, I guess, essentially a clay brick works very nicely with a cement mortar in that when cement mortar starts setting, it starts to shrink, but the clay brick takes moisture from that cement mortar and expands slightly. So you've got the shrinkage of the mortar and an expansion of the clay brick, only to very minor amounts, but the combination of the two is a relatively stable thing when they're put together. But the brick manufacturers want to also ensure that stays that way. So the bricks are not too thirsty, wick too much moisture. So this here, well, I'll pass around a modern brick and an old brick at the same time. Let you make a comparison. Oh yeah, old brick's right now. Notice the old brick is a bit pre-dimensional standard. So that's. So note I guess essentially you could imagine the difference in the wicking between those two. So that old brick still relatively porous and sandy and has the ability to wick a great deal of moisture, whereas the modern brick is quite well fired and very dense and not so sandy, and is not going to be as porous, and it won't have the same suction on the mortar as the old brick. So that type of brick, slightly more difficult to lay because you slap the mortar on and it has a tendency to slide off. These older bricks, you slap the mortar on, because they have such good suction, they will hold that mortar, but they'll draw more moisture out of that mortar as well. So the mortar won't be as strong, and it'll also shrink more. So bricks have great fire resistance. So you need, I don't know what temperatures you need to go significantly damaging a brick. But yeah, typically it's the mortar that goes first, and even with fire damage properties, typically you can just break out the mortar, replace the mortar, and the bricks are fine as long as they're not too stained from the fire. So they take quite a lot of heat. Their size enables easily handling and placement in walls, can easily adapt to small scale, large scale structures. Bricks can give a pleasing appearance and texture. So I think that was some marketing material grabbed from brick manufacturers' site, that particular thing. But yeah, typically with glazed bricks, etc., you can achieve quite a modern aesthetic with those. So moulding of bricks, the raw material is dug from pits, crushed, ground and screened to produce it into a fine consistency. Then it is tempered with water to produce a plastic clay ready to form into shape. So to get the right plasticity, right amount of water, form it into shape, trim them up and fire them. It's pretty quick and easy. Fairly energy intensive though. So the length of a clay brick is, and so this is just some dimensional standards. So we know our bricks, our length is 230, our height is 76, our width is 110. Very important thing to remember. This is less so important. This is just about some dimensional standards of the bricks. So length of clay brick is to be not less than 1.5 times the width, nor more than 390 millimeters. The height is to be not more than 70% of the length, with the gross volume of the unit not exceeding 0.004 cubic metres. So that's not so important for us because we're not making bricks, we're just specifying them. But this information is important to us. So 231.10.76, modular bricks, 290, 90, 90. I think this one's a 290 modular brick. 90, I reckon. Yeah. So 290, 90, 90 modular bricks. Now,
Pretty solid, that one.
yeah, why would someone want to make a, so if we've got our standard brick of 231.10.76, why would someone want to make a brick which is 290, 90, 90?
Less bricks to load.
Well, yeah, less bricks to lay, that's true. Oh. Come in. Hey, there. Just talk about bricks and passing bricks around. Have a good look. So, yeah, so 290, 90, 90. Well, the thing is, if we add 10mm mortar gap to the side of that, 10mm mortar gap to the bottom of that, we've got something which is 300mm long, 100mm tall, and if we have a mortar gap to the side, it's 100mm wide. So it's a very, how do I say it? It's a little bit more modular. You'll probably notice, and you probably continue to have this reaffirmed as you get more and more involved in building, is notice how often the increments of 300mm turn up in buildings. Things like our plasterboard sizes. Can anybody tell me some standard plasterboard sizes?
2400, 1200.
Yeah, 2400, 1200. Divisible by 300mm. Yeah. So 4 300mm or 6 lots of 300mm. Also, we got some plasterboard sizes in like small sheets in 900mm as well, and 1200mm. You know, stud spacing. Standard stud spacing is 600mm. Well, I guess that relates to the plasterboard sizes because you don't want studs out of step with those. But our stud spacing is 600mm. Our rafter spacing is 1200mm or 600mm. Our bucket sizes on our excavators, 300mm, 450mm. So that dictates the size of our footing beams. They're so the width of a bench. So the width of a bench is 600mm. The height of a standard bench is 900mm. So there's lots of 300mm popping up there all the way through building. Oh, ceiling heights 2400, 2700. So 2 or 3 meters. Very standard sort of ceiling heights. Once again, all increments of 300mm. So to have a brick, which is also, once it has its 10mm mortar gap, but also an increment of 300mm, works very well with building as well. So that's why it was done. Can anybody think why we don't build every single house now with modular bricks? Anyone seen Fiddler on the Roof? No, I won't. A tradition. Yeah. The whole thing about having bricks that are 231.10.76, it has a certain aesthetic to it. So you look at a brick wall using those bricks, it looks like a brick wall. You look at a brick wall using modular bricks, it looks like a brick wall, but something's a bit different. It's sort of, and they took off a bit in the 1980s, but then, the people sort of went back to a bit more of a traditional looking brick. That is the main reason. The other reason is that, so you can change the modular brick to be more in keeping with other dimensions within the building, but our window sizes are already predetermined. And it's another thing to go convincing window manufacturers to change all their window sizes to increments of 300mm rather than increments of a 230 brick. So good idea, but they didn't so much take off. And also, we've got jumbo bricks there, 391.10.90. They're even longer once again. I don't know that I've ever seen any jumbo bricks in use myself. I've seen plenty of concrete blocks, 390 long concrete blocks. We'll get into those in a bit. Just some brickwork terminology. So we've covered our bed joints already and our perpends. The long face of a brick is called the stretcher. The short face of a brick is called the header. And that comes from terminology around double brick laying, which we'll show a little bit later on as well. But just remember that, the stretcher and the header. There we've got a raking back, which is shown, so anything in construction which has a slope to it is referred to as raking. So like a raked eave, a raked ceiling, doesn't refer to the fact that there's exposed beams, it refers to the fact that it is on a slope. So raking back is on a slope. So you don't see that very often unless, one of those sort of late 70s, early 80s Spanish style places that had quite a few of the arches and the raking. What do they call them? I can't remember the correct term for those walls that stick out. So vent brick, you'll see that for ventilating subfloors. We've got arras, so the corner of our brick is called an arras. I don't have any tumbled arras bricks here, but can anybody imagine what I mean when I say tumbled arras brick?
Gordon?
Yeah. Maybe this is putting in a spot too much. If I had a house built of tumbled arras bricks, what sort of age range would it be in when you think it would have been built? Yeah. So tumbled arras, I was putting on the spot a bit much for that. So tumbled arras bricks are a bit of a thing of the early 90s. So I'll see if I can get an image up for you, because it's something that you will, you see it, you are, well hopefully, if I keep saying that. The tumbled arras brick wall. Let's get into so does that scream early 90s? Yeah. So it's that thing of, you've got some soft bricks. I'm not sure exactly how they manufactured them, but they had some bricks and then they just roughed the edges up a little bit, looked a bit sort of faux rustic. So that's tumbled arras. If ever you need to describe that, anybody. Also, a very important thing to have in our brickwork is a weep hole. So that's a gap at the bottom where our perpend joint is left open, so moisture can exit. I think we've covered everything there. So half bond, that relates to this, well, it's called half bond in there. In South Australia we typically call it stretcher bond. So it's where you've got your bricks laid like that, essentially. So none of your perpends are laying on top of each other. They keep going like full span of brick or half span of brick, which works very well also once again with brickwork dimensioning, because your bricklayers cut all their bricks in halves. There's some other masonry units. So adobe or mud bricks, so pressed straw and mud. Don't see a lot of that happening now either, although if you travel around the world you see a lot of it. If you're at South America, certainly saw a lot of it in Iran, Middle East. There's a lot of baking with mud bricks, so it's a very common thing around the world. Doesn't fit so well into our building code of Australia. Once again, that insulation thing is an issue, because you build with mud bricks because they have a low embodied energy, but also because of their thermal mass. You want to keep that thermal mass inside. If you have to insulate on the outside, you lose that aesthetic, etc., etc. It's no longer so simple. Rammed earth is not actually a type of, well, typically it's not a type of masonry, but you can get rammed, so what do you call them? They're like rammed earth blocks, but there's another term for them. Compressed earth blocks, I think they're called. So there's a small machine that you can, like foot-driven machine that you can use to make your own pressed earth blocks, and then you use them in masonry construction. Oh, there we go. Oh, pressed soil blocks. Straw bales and render. Well, I guess possibly straw bale comes under the terms of masonry. We've got individual units. We're not mortaring them together, but they are essentially individual units at a stretch. You can include that in masonry. Has anybody ever seen a straw bale house? Straw bale built house? No.
Only on grand designs.
What's that?
Only on grand designs.
Yeah, only on grand design. There are a few about the place, certainly about the place here in SA. There's a spot right in the city called Christie Walk, which is on Sturt Street in the city, so not that far from the central markets. That's got a lot of 3-story straw bale houses. So yeah, it's an inner city, high density development using a straw bale. But then there are other straw bale places just dotted around the place. I know there's one in Meadows on a road that I drive past a lot there, but out at Gawler, there's a farm out there. There's a bunch of straw bale places. It's an interesting form of construction, and I did a bit of work on a friend's straw bale place as well. And a lot of the straw bale places I've seen have been a bit sort of noddy house, a bit sort of rounded and so on. But with a good professional renderer, you can actually get a really good rendering job done on a straw bale house, and it really looks the part. So I guess that technology doesn't have to be confined to just that arts and crafts kind of aesthetic. But rammed earth, definitely some really groovy stuff happening with rammed earth, except once again, the new requirements of the National Construction Code and the insulation for external walls is a problem for rammed earth, and so we don't see that happening so much anymore either. Can anybody think of a significant rammed earth building in Adelaide? It's putting you all on the spot a fair bit. I'll narrow it down. So North Terrace and Hackney Road. You know, think of that. Let's see if I can grab an image of it. One that shows nothing really showing off. Oh, there's some photos with some close-ups of this rammed earth wall. So anybody seen that place on the corner of North Terrace and Hackney Road? So we've got our big wine barrel timber slats around the outside there like that, or Noah's Ark, either way. But then in behind that is a massive, big curved rammed earth wall. I think it's beautiful construction and beautiful concept. So what they did for that is they brought in soil from the 7 major wine regions around Australia, and then produced that wall with the soil that they had brought in from those various areas. So, linking that whole thing about, terroir in wine being about the soil that they grow the grapes and all that sort of stuff. Linking that in with the actual construction, so the place is built of the soil that supports our wine industry. But there's a bunch of other not so prominent but pretty cool rammed earth places around in SA as well. You'll see one in McLaren Vale as you're heading into McLaren Vale. So heading south on your left hand side there's a tourism centre there, that's all made of rammed earth. If you head all the way down to Yankalilla, the Yankalilla High School has got a rammed earth sports, like a gymnasium. I haven't actually been in it. I see it from the outside, but that's a pretty cool looking building as well, done with rammed earth. And there's a whole housing development in Wollonga that was all built with rammed earth as well, which there's some pretty cool designs in that. So yeah, it is a beautiful material, but it has its limited applications. What I think it's still a very good application of rammed earth is as a central spinal wall in building. So you get all that thermal mass inside the building. It's great in load bearing. It's really poor in insulation, so you don't want it externally, but it's great for thermal mass and getting inside the building, and it's a beautiful feature as well. It's a lovely. Well, I think so. Each their own. I think that's all. A bit subjective. What we've got there, a few images about concrete blocks. So, is anybody think of another name for a concrete block?
Besser block.
Besser block, yeah. And that's typically the name, like that's a trade name, but it's it's one of those trade names that's been synonymous with the product. So whenever anybody talks about concrete blocks in SA, they typically say Besser block. So yeah, it's got a bunch of Besser blocks there, and they come in, how to say, in different styles and shapes to a degree, pertaining to how they're meant to be laid. So we have some concrete blocks up here with accommodation for reinforcing cut through. You also get some concrete blocks that are interlocking, so they lock onto the other concrete blocks just by a bit of a toothed mechanism at the top for making retaining walls. Different colours added to the concrete, so you've got some really dark grey ones, some really light sandy ones. One interesting thing about concrete block manufacture is to get these dark, well not darker, but more greyish hues in a Besser block. That's the ones that are produced in winter time. The sandier, slightly yellow toned ones are the ones that are produced in summertime. I don't know why that is, but I went to buy Besser blocks and I talked to them, look, I see that there's some slight difference in your colouring. I don't really want the sandy yellow ones, I want the greyish ones. And the lady selling the Besser block, well, this is just over the phone, she said, well, the greyish ones, they're the ones produced in the winter time. And I guess it's because they're typically producing these blocks. Well, I can only guess really. I should have asked her why that is the case. But when you're pouring concrete slabs on site, you use different concrete in the winter than you do in the summertime. Because in the summertime, you want the going off of that concrete to be retarded. In the wintertime, you want that going off the concrete to be accelerated. And so the different concrete properties, and possibly that flows into why our Besser blocks have a slightly different colour. But if you're a stickler for, you want really that colour, because that colour works well. We just want natural faced Besser blocks, and we want it to work with certain colours. Be aware of that. That's a winter time. That's a summertime. There's some Hebel down there. Great thing about Besser blocks or concrete blocks is that they can have steel reinforcing added through the cores. And I don't have a Besser block here. They weigh 16 kilos each. They're a bit heavy. But with our Besser blocks there, when I go laying another one on top of that, the accommodations, those channels line up perfectly, even when I've got them staggered half, because there are two accommodations in each. That allows you to run reinforcing vertically up through one of those holes and fill that with concrete. So basically creating a concrete pier with reinforcing that's bonded on the inside of a wall. So that might be that you fill all of them with concrete and have reinforcing in all of them, or you might just do that every 1,200 centres or so. So every sixth hole you will fill with concrete and have the reinforcing running up there to create piers within your wall. And I guess that's what's happening here in this scenario. That they've got reinforcing poking up over the better blocks there, and they probably core filled those. So they make a very good, easy formwork for the creation of those concrete piers and integrating those piers into a wall. Some groovy stone architecture, brickwork. Excuse me. So bonds defined as the arrangement of masonry units in a wall. So you possibly, if you're getting into more the history of architecture, you'll cover various different bonds. Some bonds that you'll see about place too. Yeah, you won't see English bond so much, but that's where you have a row of stretchers, a row of headers, a row of stretchers, a row of headers. Flemish bond you'll see around a bit more. That's stretcher, header, stretcher, header, stretcher, header, like that. What that means, that's when we build what's called a double brick wall. And I have to make that distinction between double brick wall and cavity brick wall. Double brick is where we have bricks shared between the two leaves of brickwork, and we have a 10mm mortar gap between. So we end up having a solid wall that's 2 brick widths thick. A cavity brick wall is where we have a single leaf of brickwork, a gap, and then another single leaf of brickwork. So, is that fairly clear to everyone? Because a lot of people say, oh, it's a double brick house, when it's actually a cavity brick house, or so. But yeah, a couple different bonds. That all relates to double brickwork. So a lot of that, I guess, is really only relevant to architecture history students. We're not really dealing with that too much these days. So once again, some more bonds there. So yeah, here we go. That's cavity masonry, and that's double brick. Not cavity brick, double brick. Okay, mortar, very important, but not really the domain of the designer. So some basics around. So mortar mixers must comply with AS 3700. So this Australian standard on masonry. General purpose mortar, 1:1:6. So 1 cement, 1 lime, 1 sand. But it takes a braver person than me to go and tell a bricklayer how to mix their mortar and go, look, 1:1:6. I'm not going to do it. But yeah, so mixing process is called batching, carried out by volume. It says use gauge boxes and not by shovel. So a lot of bricklayers, do it by eye as part of the art. But the Australian standard says yes, it must be a controlled system. So that's a bit, I guess, your nexus between how it's done on site and how it's defined in the standards. Bed joints and purlins should be 10mm width. Joints are formed as work progresses. The process of forming a tooled joint after work is complete is called pointing. We've got a couple of pointing trowels in here. Try to get to them that they're nearly sunk down. Do you want to pass those over to Kane when you're done? So they're a couple of our pointing tools. So the trowel is what we use for actually getting the mortar in place, typically when we're doing stone work. So that's about neatening up all the joints in the brickwork. So the pointing tool with the handle on it, that's for doing a concaved joint. And the square one, that's for doing your various different other sharp shapes. So your rake and stroke and cut.
That's called pointing.
So this here that's a wall where the pointing hasn't been done yet. So the mortar looks really rough. And what they'll do is they'll scrape that mortar off, get it flat, and then they'll dress that mortar up nicely using one of these tools. I'll see. You can see it. No, that's not a good one. So there we go. That's one where it's been done. So that's the pointing that's been done. It's all nice, neat and tidy. So a couple of different methods of pointing, possibly important for if you're wanting to create a certain aesthetic. So deep rate, that sort of gives that that minimalist, brutal sort of aesthetic. It shows up the joints very well. Flush can also be a relatively groovy mortar joint, but concave is typically what we see throughout the place. I'll just keep moving through that. It's not too difficult. Cavity minimum width 25mm, but usually about 40mm. So typically it's 40mm, but our parameters there are 25mm minimum, 60mm maximum. Stud work fixed to masonry by wire ties. It says 6 CTS there. That's actually meant to say 600 centres. So we join. Now I'll see if I can grab a wire tie out of here. That also float to the bottom there. It's a bit of an old one. So 5 or 6 years ago, all your wire ties look like that. Now they look a bit different. I think I might have to grab some new ones with that. But our masonry, it doesn't stand. Well, it stands separate to our stud work, but at every 600mm along the wall. So every 600mm along the wall, we put in a wire tie. Goes between the bricks, and we nail that onto the vertical studs. So if the wall wants to fall over, it's tied back to the timber studs. So the timber studs and the brick wall are tied together. So weep hole allowed at every 4th brick to allow moisture to exit the cavity. It says here air vents at 1 metre intervals. That relates to subfloor ventilation. So with your standard brick veneer house, you don't need to have air vents. But with the older brick houses that had raised suspended timber floors and strip footings, they had vent bricks at every metre intervals. And that's also typically how you can tell from the outside of a building what their floor height is as well. You look for the air vents and go, the brick course above that, that's where their floor vents are. Oh, sorry, that's where the floor in the house is. So here's some more typical timber frame construction. We've got insulation packed between our studs. We've got a bit of bracing board there, some sidolation, wall ties. Yeah, I don't have any images of them. Oh, that's a fairly modern looking wall tie. So that's more the type of wall tie you see now, rather than these ones. There's some vent bricks. Well, that's actually a steel ventilator. So details for that. So cavity masonry. So that's distinct from brick veneer. Our cavity width is a minimum of 35mm to a maximum of 65mm. Can be reinforced or unreinforced. Cavity ties, once again, at 600 centres. And you have weep holes for drainage. So brick ties for cavity wall, slightly different. So use same material, different tie. That's for our cavity masonry. Don't have any that look exactly the same as those ones there though. No. only got that type there that's floating around. So there we have one of those going into locking a single leaf return wall into our external wall. One way to resist lateral loads on a brick wall, typically if it's a standalone brick wall and we don't have any timber framework, is to have either intersecting walls or engaged piers. Thank you. Now, engaged piers, I'll do a Google search on that image as well, because I feel that that's one of those things that you'll see and go, oh yes, I've seen the engaged pier about the place. What's a good example of it? Got a lot of engagement photos down here. Yeah, no, I didn't think that.
Engagement piers.
Yeah. That's I guess a good example of an engaged pier. Yeah. Actually, that's a horrendous example of an engaged pier. That's a good example of what not to do when you're doing an engaged pier, actually. I'll come back to that one. Maybe that's, yeah, possibly that's what to do when you build it. Yes, it is. Yeah, great. I can see what's happening out there now. So within, this is a single leaf masonry wall. So that single leaf masonry wall, by the standards, you're not allowed to go too high with that because it doesn't have a great deal of width and it can topple over very easily. To help stop it toppling over is you can build piers into that wall. So to make a pier engaged, that means you need to share bricks with the pier as well as the wall. So it's like double brickwork where you have interlocking bricks happening within the wall. So that pier is engaged within the wall. What not to do is what's being done right there. Now, possibly they have some wire ties going between these bricks and the wall. So there might be some wire ties in the mortar, but that's really not sufficient to provide the strength that's typically required for your engaged pier. So the way that I can tell that pier is not engaged is I look down this pier and I see all stretches all the way down. If I saw a course here of 2 headers, then I go, okay, yeah, it's been done properly. If I see all stretches like that, it hasn't been done properly. And yeah, I've had issues with buildings being done with improperly engaged piers, or I had one with had a fire in the garage and things went south because or partly because of the fire, but also because of the lack of structure happening in the wall. If those piers were engaged, then possibly it wouldn't have. So that's something to look for. So they've got the idea, but not quite carried that out thoroughly in that example. So you want good bricks, good bond between bricks and mortar. So you can provide that level of support with engaged piers or intersecting walls. Doing roof tie downs to brickwork is an interesting thing. Can anybody think how we would tie a roof down to brickwork? It's a tricky one, isn't it? Yeah, so you've got this brickwork. Can you get some straps and mortar them into the top course? Is that kind of the way that you do it is within your. I don't have a good picture of a brick wall. I'll draw one just quickly. So it's our brick wall here like that, and our rafter coming down over the top. So that's coming down at an angle. Imagine that. Draw it trigonometrically. what we can do is typically 900 millimeters down from the top, directly under, we drill a 10 millimeter hole in the mortar gap. So this is some very bodgy brickwork, by the way. We drill straight through that mortar gap there, or potentially that one's the better one to drill through. So straight through there, and you tap a 10 millimeter rod through that hole that's drilled in there. Then you get your galvanised iron strap bracing, that 30 by 0.8 galv iron strap that's used for all sorts of things. You loop that around that and tie it over the rafter. That way, if wind tries to rip that roof off, we've got a severe wind event, it has to take a cone of brickwork with it. So that's the 900 millimeters. Sometimes it's also specified down to 1200 millimeters, so that will take a whole lot more wall with it if it has to go. So typically you're not going to get a wind strong enough to take a whole chunk of the wall, so it's going to be thoroughly tied down. If we had just a ribbon plate on the top of that and then some masonry anchors into our top course of brickwork, what can happen there is we just take off the top course of brickwork, and that can happen fairly easily. So that's, I don't know, 20 kilos worth in comparison to like 120 kilos worth in there, just estimates.
So is that done in the cavity?
What's that?
Is that done while you're in the cavity?
So that's done across the cavity. Now that's how to do it retrospectively. If you're doing it while building, so we've got our brickwork. There's our bricks here, another brick there like that, and a mortar gap, and then our bricks on the other side like that one there, mortar gap. The rod, you'd probably set it in there like that and that. So provide 40 millimeters coverage to each end of it, and it's set in there. And then later, so you know the locations, because you know the locations where your raft is going to come, because you're building plans, and then you wrap your strap around that later on. So doing that, drilling in and tapping the rods in, that's what you do retrospectively. So rafters can be tied down. Yeah, fixed to 10 mil rods built into brickwork, 900 from the top of the wall. We've got there a suitable tied out strap detail. Okay, yeah. So that's specifying it at 900 millimeters down from the top of the wall there. Although that's specifying 25 by 1 millimeter galvanized steel straps at not more than 1.2 centimeters. So that size strap I don't think we use that anymore. I haven't seen any of that about the place at 25 by 1. Typically we use 30 by 0.8 now. The wall ties provide strength, have to be protected from corrosion. Connects 2 layers of masonry or masonry and timber to a metal stud. So these are our wall ties. So that's brick to brick wall tie. That's brick to timber stud wall tie. This little bend in the tie is actually important as well. That's a drip groove, and they always have to face down. If we face it up, we get water on here, the water might run to the stud or run to the brickwork, hopefully run to the brickwork, not the stud. But they should face down, so even if that's on a bit of a lean, whatever, the water that hits it will still come along here and drip off at the drip groove right in the middle of that cavity, and then exit out through the bottom. Embedded 50 millimeters into the mortar joint must have a minimum of 15 millimeters cover to any surface. So for the outside of the wall, it has to be covered by 15 millimeters of mortar. Should be installed to prevent moisture breaching the cavity. So we don't want them sloping down toward the timber work. Have a drip groove or bend spaced at 600 centimeters. Typically, although for around your windows, those spacings are reduced to 300 centres. your spacings. So around your windows, yeah, quite frequent. Also at an articulation joint at 300 centimeters as well. So it's named there an articulation joint. Does anybody know another term that's used there for those? It's often abbreviated to just say BCJ, and you'll see that on your plans. Maybe you'll even see it on that plan. I don't know. Do they have any BCJs there? No, we don't. No, not specifying our brick control joints there. But typically on a floor, so that floor plan is very busy already. If we were specifying control joints in that, it would be a fair bit more. So our brick veneered walls have to have control joints built into them, because if we don't have a control joint in our wall, we have a really long run, there'll be a little bit of flex in the building and in the concrete slab, and that will just go straight through the brickwork. So that control joint enables some movement of the brickwork. So now there are expansion and contraction joints, articulation joints, and the overriding term for all of those is the brick control joint. So sometimes you'll see them specified as articulation joints there. Within the National Construction Code, it says that you need to have articulation joints at ever so often. You need to have expansion and contraction joints at ever so often. You can pull those two together and then use the minimum distance of the spacing of those and call it a brick control joint, and that takes care of both. Basically what it is, it's where we have a 10mm gap in our brickwork that goes from floor to ceiling. So here's some examples of differential movement. So a masonry wall must allow for controlled movement to avoid damage to a building. So straight away you can look at that where you see, okay, timber windows, surrounds, concrete, what do we call it, concrete sill, and older brickworks. It's an older building, so typically that may have been built before we had raft slabs, and there's a lot of movement that happens in those. That sort of movement is a bit concerning to me. If I see that sort of thing, I think, okay, there's an issue there. Why would I be more concerned with a crack going straight up than I would a crack going diagonally? Typically, and this is very, very rule of thumb there. Sort of depends on what's causing it, but why would I think there's something worse with that than a diagonal crack?
Is that because load would be pushing down from top rather than if it was diagonally, the force would not be centered?
I think you're on the right track.
Yep.
Yeah. So because I think it's sort of what you're talking about, a concentration of forces there. Yeah, and that's typically why we are concerned more with the crack that goes straight up. So we've got cracks that go straight through brickwork rather than stepping its way through the mortar. It's gone straight through the brickwork. That tells me that there is a fair, an exaggerated difference in forces happening in a short space. If there's our building here like that, if we had sort of a bit of general heave from our soil happening here, like that, then we probably get a stepped sort of crack happening through there, like that. So we've got a bit of heave, possibly a bit of subsidence happening there, like that, but it's over a fair sort of distance. If we get a crack which is doing that, then we can be sure that either we've got a lot of heave happening right, so very strong heave happening right at a point next to something that's dead stable, or possibly heave happening next to subsidence shearing that. And that will typically result in more issues. That sort of thing typically opens up and closes with a bit of seasonal moisture swelling and contraction, swelling and contraction. That vertical cracking is typically something that relates more to a, how to say it, not such a seasonal issue. There's something drastic occurring. But in modern buildings, to ensure that we don't have that happening in modern buildings, we have these brick control joints that happen at the sides of openings, and if it's medium class soil, then it's every 6 metres. If it's reactive soil, then it's every 5 metres, typically. So refer to your AS 3700 for that. Some building and engineering firms just specify every 5 metres for brick control joints, just to cover it all. So the brick control joints, the one that we can see here is this type, where we have a foam backing rod and then a mastic seal on the outside of that foam backing rod. That ensures, or helps ensure that no moisture is going inside that brick cavity. If it were an external wall, we're not so worried about moisture, like a wall in the garden, not in the house, then just those foam backing rods get pushed in place. I think we've got some foam backing rod floating around in here. Yeah. There you go. So if we're doing a brick control joint between the house and the fence, well, then just a bit of foam backing rod is fine. If we're doing it between the house and the extension, then we want mastic sealer on that. So any openings that are greater than 900 by 900 require articulation joints up the side. And, well, so yeah, once again, articulation joints, well, I'll call them brick control joints because brick control joints covers everything. But a lot of builders sort of chuck extra ones in as well, I noticed. So even on some smaller windows, like that be 600 wide, they get dropped in at times as well. So vertical control joints placed in positions which does not compromise the strength of the structure. 3700 requirements are: opening movement of joint must not exceed 10 millimeters, closing movement must not exceed 15 millimeters, width of the joint must be not less than 5 millimeters, fill material mastic not to impede the movement of the joint, and not to be toothed into a masonry wall. So that, I think that is all fairly, how to say it, fairly sensible, really. You know, if you've got a 10 millimeter brick control joint, you're not going to have closing movement exceeding 15 millimeters, and so on. With the control joints, you still want to tie the brickwork together, and that is done by ties that can slide or expand. Got an expanding one here, pass around, so it's a brick tie across the joint, expand. Oh yeah, here's the sliding one. So here's a floor plan showing some brick control joints. Well, they're termed as ARJs. So that's an articulation joint. Typically, you'll see BCJ written on plans, or quite often you won't see BCJ written on plans as as well, and the bricklayers will read the plans and interpret where the brick control joints need to go. But here we have a very long run of brickwork, and so because that's quite a long run, we need to have an articulation joint run in the middle. Thank you. So vertical articulation joints are used to counter movement of footings, allows walls to move in relation to footings. Used in unreinforced masonry in reactive soils. Well, it's used in unreinforced masonry in all soils, but typically it's good to deal with those reactive soils. Straight continuous walls with no openings. So what says at maximum 6 metre centres there. Some rules just simply specify them at 5. At locations where there's a change in wall height, you have to have an articulation joint. So you've got wall height that's high and then some roof or something, and then a wall height which is low. You have to have an articulation joint there, because that's where, if you don't have a joint there, that's where it's going to crack. So, or a change in wall thickness. When you get a change in wall thickness, that's also a weak point. So you have an articulation joint there. Add a control joint in a slab. Typically, you don't have control joints in slab for residential architecture, but if you, oh no, that's not a control joint there. That's just a construction joint out there. But as you walk out of here tonight, have a look at the floor right down the bottom there, and you'll see a whole lot of saw cuts that have been placed into the slab and then filled with mastic. That's no accident. They've been put in there on purpose. That's to ensure that the cracking of the slab happens in those locations. The reason we want the cracking to happen in those locations, we want to control the cracking. We want to ensure that it cracks where we want it to, not in a crazy pattern, which is going to be unpredictable. And also, then if we put a saw cut in it, we can fill that saw cut with mastic as well, and it can still be relatively smooth. So, with some forms of construction, you have to put control joints into the slab. If you do that, then you have to carry that control joint up through the wall as well, because it's going to create a point of weakness or a concentration of forces there. Walls constructed of different materials need a control joint, and deep rebates for service pipes. So where we have a weakening in the slab, then we have to have a control joint there as well, because it's also a place that's got to transfer a load to the wall. So a couple more details there. Various different wall ties, control joints. Alright, about to move on to concrete block masonry. But before we do that, I think take a slight break, or in terms of having a look at our plans and our brick coursing chart as well. So, just as a bit of sorry Tommy, I don't have the brick coursing. Come over and use this one here. You guys can join together, because I don't have a spare. I just went and did this when there's a few people drive past. So probably a good way to start this and to have a look at this and to think about it is to see the dimensions here and think about which ones relate to brickwork. So Kane, are you able to show any of these? Just draw a bit of a mark, because you've
The 240.
Yeah, that's going to relate to the wall thickness. Yeah, I guess that certainly relates to our brickwork. But typically more the dimensions I think that are going to relate to our brickwork there, ones like that 840, because that's from there to there. 1810 relates to our brickwork, because it's an opening within the brickwork. 1470. So this row of dimensions here is one that's relating significantly to our brickwork, like that. And 770, that one there, relating to our brickwork. This row of dimensions in here. So what I'll do, I'll pop around to everyone's there and I guess sort of highlight our row of dimensions, which
Sort of the inner one.
yeah, it's the inner one. Yeah, it's consistently that inner one there on our plans. So if you could, so we've identified that now. If you guys could go back into Moodle, back into Learn. Oh, well, you can stay there with that chart. Pane. Open it up. So just open up that brick coursing chart, the linked brick coursing chart. There. So you've identified that fairly well. Yeah. You share
So
that.
where we have
Dean,
like
yeah.
windows and that,
Yeah.
how does that work if there's bricks lower above?
What do you mean?
Like, obviously you got bricks there,
Yeah.
there.
Oh, so for the height of your window,
Yeah,
yep, that's in increments of 86 millimeters.
right.
Yeah. I'll do a quick Google search for the standard window size. I'll see if I can get that on the screen next to our brickwork dimension chart and see how much
Yep.
we can see. Yes, but yes, brickwork dimensioning works in a horizontal sense and in a vertical sense as well. So have a look at that, and then open up your brickwork coursing chart and see how many of those dimensions you can find within your chart. So yeah, typically the lines of dimensions we're looking at. So this inner line here, and that line there, these lines, and that one. So inner lines of dimensions relate to that. So that 840, that's right from that corner to there.
Yeah.
So cool. Yeah. And so yes, yeah. So that's relating. Yeah. And also this inner line of dimensions there, and this one here, that is relating to our brickwork. So just go through those and see how well they match up with your brick chart. And what I think you've got to find, I haven't poured through this one and checked it for its brickwork dimensioning, but also what you'll find is on your brick coursing chart there, you'll see some measurements where you'll see a measurement on your floor plan, but the measurement on the chart is either 10 millimeters below it or 10 millimeters above it. That dimension, that relates to a mortar gap, and I'll explain that in just a sec. I'll get my brick coursing chart up as well. So I think we have a length of a brick wall there somewhere at 840. Now if we look at our brickwork chart here, we see 3.5 bricks is 830 or 850. So why has the drafter specified an 840 long wall? Anybody think of why that would be? So our 830, that's a length of a column, and our 850 is the length of an opening. When we have a re-entrant wall happening, so we've got or re-entrant corner happening, so this is our brickwork here like that, it's happening in there. We have a 10 millimeter mortar gap here, and then, our 3, 2, 3, bricks get a bit smaller as they go on. 3.5 bricks, each with their 10 millimeter mortar gaps. What we end up having is one 10 millimeter mortar gap more than if that was just a column of its own. So we end up having, so our measurement there on that plan of 840 actually corresponds perfectly with our brickwork dimensions, because we have 3.5 bricks plus an extra mortar gap. So have you look at that plan. Does that plan has that plan been designed very well in regards to brickwork dimensioning? You see a lot of that happening in place. So while you keep looking at that, assessing that, I'll see if I can make this guy a little bit smaller, and then get a window size table up as well. I couldn't get that. I couldn't get a plan. Couldn't open up two Internet Explorers, unfortunately, working side by side. But you guys have got your two screens there. But you've got your brickwork dimension charts there in front of you. Oh, that's a bit hard to read from this distance, isn't it? Let's see if I can expand that a little bit. And I'll just move it down a little bit as well. And across. So, with your brickwork chart there in front of you, I guess you'd probably see some very similar dimensions happening there as well. So, for the width of our bricks, things like 610, 730, 850, 970, 1090, 1210, etc., 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 you're going to see those in your brick coursing chart. I'll just make sure of that. And then for our heights, so 600, 772, 944, 1030. Just come and check your chart again for our heights. So we've got our widths, and then we've also got our vertical, so our height. So our heights, so we've got 600 plus a 10 mil. Well, we've got 600 in our thing. We've got 772 in our thing. 944. Do we have a 944? We've got a 943 millimeters in our brick coursing chart. So 1 millimeter off. So we've got sizes of our windows that correspond directly to our brick coursing chart, and that's no accident. This standard window size, by the way, I just went to Steg Bar website and got it from there. So I'll just in that bit smaller again. So just one of their standard brochures or their standard sizes. But I could have gone to any of the window manufacturers and found basically the same chart with the same dimensions, etc. Anyway, so that's yours to keep, plan, and also that reference to the coursing chart. That's a good one to grab. Yeah, so you got 2 plans for the price of 1.
Yes.
Yeah, I did it double-sided. Yeah, you guys can fight over who gets what side. Alright. So moving on from bricks to talk a little bit more about concrete blocks. With our slab, I was talking about control joints earlier on. We want to put cuts in there to control that shrinkage of the concrete as it hardens. We also want to do the same with concrete masonry walls. And I did mention earlier as well with bricks, the suction of a brick works well. The shrinkage of a mortar gap in a brick works well with the expansion of the clay brick in that wall when it's freshly laid. With concrete blocks, you get, if they're relatively fresh concrete blocks, they haven't been sitting around for a while, you get shrinkage of concrete blocks with the shrinkage of the mortar. So that can certainly be an issue. I saw it as a significant issue in a house. I was doing a final progress inspection of that house, and I had control joints about this wide in there. So we saw our control joints before, how we've got that foam backing in there. Sometimes it's done with a long skinny foam, and that was all just going like this in the joints. The reason for that is they've used concrete bricks, so smaller cement or concrete blocks that were relatively fresh. They hadn't shrunk down yet, and then with new mortar as well, and that shrinks. So the bricks were all laid, and then just the walls just shrunk like that over a fairly short period of time. So that's a fault of the manufacturer of the bricks, that they sent the bricks out too early. They hadn't sat there for long enough to shrink down correctly. But we can control that shrinkage to an extent within a wall to ensure that so any gaps we have opening up are at our control joints. And the way you do that is with various different types of ladder mesh. So within your walls, you lay down some ladder mesh, and that does the same thing as that mesh at the top of your slab. It makes all the shrinkage uniform throughout the whole piece. So it consists of 2 steel wires, 3mm diameter, welded in a ladder pattern. Placed at 600 centres above and below wall openings. Very important to prevent moisture penetration into masonry. So the way that we do that is by introducing this embossed film. So that's the damp-proof coursing. That damp-proof coursing is also the same material which is used for flashings as well. So flashings within your walls. The flashings are there to direct moisture outside of the wall. So the flashing is attached to the timber frame and then slopes down towards the masonry wall and sends all the water out. So our damp-proof coursing is an impervious layer of material placed in masonry wall between floor and wall to prevent upward or downward migration of moisture. Flashing defined as a strip or sleeve of impervious material, gauze, steel, polyethylene, lead, shaped or dressed to provide a barrier to moisture in roof junctions of wall openings. Thank you. So damp is a significant issue in older houses. It's not so much of an issue in modern houses. They've pretty much got it sorted. Although talking about progress payments earlier, I also did a final progress payment on a house that when I went to look at it, they hadn't put damp-proof course all the way around. There was a section in a wall where it was missing. I don't know whether they ran out and then just decided to just keep building or what. Super cheap stuff. Why you'd not do it, don't know, but that's a significant issue to rectify. I think they had to put a saw cut through the mortar and slide it in and then repoint. It's probably not a job that I would want to be involved in. But of course you can't sign off on a final progress payment to a bank without it being built properly. So it's a very important thing to be aware of. So dampness can happen from typically in old buildings just from wicking moisture from the soil that just occurs naturally, or it can be as a result of defective plumbing. Condensation is also a significant one, where you have poorly insulated roofs. You've got a nice warm house, and then that warm air, which has a lot of moisture in it, collects at the ceiling where you don't have any insulation. That ceiling is quite cold, you'll get condensation happening on that as the air is cooled down and deposits its moisture. You have it where you've got a bridge cavity walls, blocked weep holes, so the weep holes get blocked by various different bits and pieces. So ineffective flashings and DPCs. Also, I guess you see a lot of damp in buildings where the transition of moisture through a landscape has changed over time. So originally you would have had some areas where the moisture would be directed off in another way, and then people built raised garden beds or whatever and changed all that, and so you have dampness happening in buildings as a result of that as well. So damp moisture can penetrate through external cavity and down inside the face of the wall. Cavity must be clean and have uninterrupted damp-proof course and flashings over doors and windows. So our flashings extend past our doors and windows, so that if any moisture gets in that door or window, that is directed down. Bricklayers have to ensure that excess bits of mortar are removed. So it's their process as they're laying the bricks to remove those excess bits of mortar so they're not all dropping down into the cavity. Various different ways of doing that, with a board, with leaving every fifth brick out to access the cavity. Use cement bags. You old cement bags and pack them in that gap, in that cavity in the wall to collect all the excess moisture as well. Excess mortar as well. Various different flashings here. So this is a flashing at the base of a sheeted wall directing moisture out. It's a flashing that's tied into our brickwork at the change of roof to wall junction. Flashing at the base of the wall to direct moisture from the timber frame out through, and then probably have a weep hole here when all that brickwork is completed. So over openings must extend 100 mm past the side of the opening and extend across the cavity. Must turn up 150 mm and be fixed to the timber frame. Parapet flashings are also important. Parapet walls are where we have a wall that extends past the height of the roof. Typically a parapet wall is used for commercial construction, for shops, etc. As you drive down South Road, exiting here, you'll probably notice there's a whole, we drive down any major road really, you'll see where shop fronts have a wall that extends past their roof, works well for signage. It also creates a very, a very business-like aesthetic to a shop front. I don't know how else to explain it. But so that's typically use of parapet wall, but parapet walls can be used in residential architecture quite a bit as well. And so those parapet walls have to be flashed correctly as well. So you need a capping on the top, and then you install a flashing at the base here onto your sheeting, and then a flashing which overlaps that. So flashing is not about being watertight, but it's about directing moisture to where you want it to go. So if we get rain happening on the side of this, on the back side of this parapet wall, flows over that flashing onto that one, then onto the sheeting. I prefer this detail to that one there. That's where you have a weep hole in your building going back towards the roof. That's where you have a weep hole going back toward the outside of the building. This detail tends to cause staining on the front of parapet walls, which is not too desirable, whereas this detail sends all the water back in, and you get less staining on the front face of your wall. concrete reinforced or steel lintels can be used to support masonry over openings. So the way we, in a brick veneer building, the way that we get our brickwork to span over top of our garage opening, one of these, pass it around, so that's a section cut out of a steel lintel. But also steel lintels are used in your cavity brick construction as well. So the larger the opening, the larger the lintel needs to be, and a typical lintel manufacturer, Prada, will have their tables saying this is the size of lintel that's required for this particular opening. So here are a couple of examples of manufactured lintels. This one here is not only carrying the brickwork, but it's carrying a suspended floor as well. So that's a delta core flooring system. So it's a hollow core concrete slab system. We've got an I-beam over here going down to some load-bearing structure, I assume. That's taking the weight of this, but then we've got a thick flashing happening over there that's strong enough to support the brickwork. Some more typical lintels you'll see in brickwork, brick veneer construction. And a couple older lintel details. So those details are fairly old because we've got single leaf masonry and cavity masonry shown there as well. But it's showing the various different sizes of steel and the spans they can achieve in the various different scenarios. So for construction type A, brick veneer, that's typically what we're designing with. A 90 by 90 by 6 EA, which you should all know what that relates to now, will span 3.01 metres. 90 by 98mm equal angle. Also do the same span. If we want to increase that span up to 4.21 metres, so a 150 by 90 by 8 unequal angle. Do that. Right, and that covers all of our masonry. Anything you would like to have had added into masonry, or anything you think important, or things you've noticed, seen about the place, you might not have covered in tonight's session relating to that. One thing we certainly have not covered is the assignment 2. So that's now available for everybody to have a look at. So I'll get on to do the, I'll say marking in inverted commas of our assignment 1. Just a bit of a technicality, because there's some things that I haven't done. I can't actually go recording, so done in terms of training and stuff, because there's just new requirements for training. I've been working as a lecturer now for 4 years, but got to do some more things. So I can't actually enter your grades yet. So you'll see in Learn that next to your assignments, I'm not entering a grade next to it. I'll just provide you with feedback comments. So I can't actually technically be signing off on anything at the moment. I'll be doing that in a couple of months' time. But for now, I'll provide you with feedback, and I'll get cracking on that probably this week for all your first assignments there. But just to let you know, just in case any of you were wondering what's going on with that, he's forgotten to record a grade. So I'll get onto that. But assignment 2 is up there for you to have a look at if you wish. Now, I say if you wish, probably a good idea to get onto it as soon as possible. I've trimmed a bit out of it to make it a bit quicker and easier, because the first one we pushed back a bit. Wanted to make this one a bit smaller, and I think we could lighten it a bit and still meet the requirements. So it's up here, and this should be really quite familiar to you. So just quickly go through the requirements. So you're required to do something very similar to number 1, but it says research and evaluate 2 different structural systems: the roof, walls, suspended floor of level 1. So now we're talking about a suspended floor, so we're not talking about a slab on ground or anything. Whatever we do is suspended. Could be a concrete slab like this one, suspended slab. Could be another structural system, a steel structural system or a timber structural system, whichever you wish. It's important that you have a look at the National Construction Code, and I'll show you this a little bit later. But you have a look at the National Construction Code and see what it says in regards to fire and fire safety from having a garage underneath that floor. So with your various different aspects to look at for each structural system, it says what class of building is it? What type of building is it as defined in the BCA Part C1? So we need to find Part C1 and work out what type of construction it is in relation to its class. So you have a class, and then you'll say there would be either A, B, or C type construction. And then with each of those A, B, or C type constructions, there are minimum fire resistance level construction requirements required. So some of those fire resistance requirements will be that a wall has to resist, or a floor has to resist fire for 90 minutes, 90 minutes, 180 minutes, or it might be 180, 180, 180 for all of it. It depends on the type of construction. So that can be a bit of a process. I encourage you guys to try to work that out for yourself initially, but we can cover that in class when you get back. So, or if you have any, how we do it? Well, we've got another 40 minutes. I'll see if I can bring the BCA up and we can have a quick flick through that tonight before we go. But yeah, we'll have to make that fairly quick, and you'll have to, I guess, essentially take a few notes, but then also go through that process yourself at home. So cladding, also brought that down. So research and evaluate 2 different wall cladding systems. So we've brought that down. So you can choose between those or anything else you wish. Once again, all your headings in relation to advantages, disadvantages, limitations, environmental impacts, etc. And also very similar to number 1, we're not doing hot water services this time, we're doing air conditioning systems. So compare the advantages and disadvantages of different air conditioning services. Refer to learn further information. Make a recommendation to your client based on your research and indicate the location of the service on level 1 floor plan. And that note that I had in Assignment 1, where pertinent, include structural details of the building systems chosen. These details may be sourced from manufactured product literature, etc. That should be a very familiar comment. So you have to think about what sort of air conditioning service you'd provide in that building and where you would be locating that service or services, plural. So I'll bring up the building drawings. The Assessment 2 drawings. What we're dealing with in this one is, I think, a relatively poorly designed multiple residential building. But that beside the point, we have a lower floor, which is a car park, and then an entry off that car park, Then we have 4 units above that car park, each with the access and balcony at the front. So very small bedsit units. A very inspiring external aesthetic. What you'll notice is we've got columns at the front here, so the building has columns. You can take them out if you want to. If you go, oh, we can do a fantastic floor system that can span that distance, by all means, take them out if you wish, but you've got quite a span there. What is it? 16.8 metres. That's certainly a very, very large span to achieve. So good luck doing it without columns. But for that car park there, we've got dimensions there. We've got 13.3 metres span back that way. You might not be able to achieve that with various different materials, and it might require introduction of other columns within that car parking space. It's probably good to mention that as a drawback with that particular system as well. So that's our external, very, very normal sort of building there. Nothing too spectacular about it, and there is a cross section through it to get an idea of that.
So if we come up with a floor system that needs more columns, do you want us to show a drawing of that?
No,
Or
just make mention of it.
At certain distance, whatever centres and.
Yeah. If you've got that information, by all means, yeah. But you can say by using this timber beam floor, we can't achieve that required span of 13 metres, and it requires the introduction of intermediate columns. And that's probably good to say 2 rows of intermediate columns, or let the client know how many intermediate columns, because that will really dictate how restricted the use of that car park is. So I guess try to get those details in there. But that can also be a significant amount of work as well, determining that. So I don't expect you to go. Yeah, I'm happy with just a statement of intermediate columns have to be introduced. So that's our assignment in our buildings. Any queries or issues with that? I don't expect. So we're starting to use not so much commercial materials, but some materials that are different to what we would have used in the residential architecture. Obviously, there's a lot of crossover there, and you could use similar materials as what you did within your residential. But certainly that floor is different, and there's quite a now you have to find specific answers from the National Construction Code as well, and tell us about the class of building, what type of construction it is, and what the fire resistance levels are.
So with the drawings that have got like the first floor level of roof and the ceiling levels, one at 3 metres, one at 6 metres.
Yeah.
Depending on what different floor system you go with, you'll get different thickness of floor.
Yeah.
And so if they end up being like 2700s or something like that, is that an issue?
Well, it certainly should not be an issue for the lower floor.
No, I mean like maybe for the roof level.
Yes, for the roof level. But if it's a flooring system that you change, it ends up being a very thick floor. as a designer, I'd pinch all that from the lower floor,
Yeah.
because down the lower floor we've got car park and we've got storeroom.
Yeah.
We don't really need 3 meters, head height for a car park.
Yeah.
And I'd be pinching it from that and leaving the ceiling heights in our apartments alone.
Yeah, because that's the only reason why I bring it up, because I sort of had a look at it last night, and then, it's not just the floor, but you've got the plumbing and any services
Yes.
in
Yeah.
that roof space as well in the car park
Yeah.
that you either have exposed or you have sitting on.
Yeah. And so you can very much start increasing the depth of that, and that can be an issue. And that's something I don't expect you to once again be specific about. Say, look, we've had to go to 450 deep floors, which means we're intruding on that lower space. But 250, I don't expect that level of detail.
Yep.
But I do expect you to say the use of this system increases our floor depth. We might have to. That might mean a lower ceiling, or it might mean a higher ridge height in our roof. That has to be accommodated for. And with a higher ridge height in our roof, there may be some issues in regards to council approval.
Yep.
Yeah, that's a good thing to have. Some possible answers there. But you don't have to get too specific about the construction of that. Interesting. It's not asking me here for my. Here we go. So has everybody accessed the National Construction Online yet? Yeah, great. I was expecting some people to duck under the tables at that point. That's good. So here we are, we've opened it up. First step we want to work out is what class of building it is. So you look down through our major headings there, it's not really showing us. So it's typically right at the start. So let's go to general requirements. If we expand that general requirements, we've got classification 1.3. So just click on that, takes us straight there. So here we have class 1 and class 10. Oh, that's right, because I grabbed volume 2. Might go to volume 1. So NCC. That's amendment. One amendment. NCC 2016 volume 1. It's been superseded due to amendment that occurred out of cycle prior to the NCC 2019. Please, one amendment to the current edition, okay? So, NCC volume 1 amendment covers the whole thing, I assume. So I wonder what they've changed. That is interesting. So, once again, general requirements, classification of buildings and structures. So read through that. We get to class 2, a building containing 2 or more sole occupancy units, each being a separate dwelling. Sounds pretty similar to what we're dealing with there. So we have to go to part 1C, so section C, fire resistance, or part C1, sorry, fire resistance and stability. Type of construction required. The minimum type of fire resistant construction of a building must be deemed in accordance with table C1.1, except as follows. Except certain class 2, 3 or 9C buildings in C1.5. So go down to that, 2-story class 2, 3 or 9C buildings. A building having a rise in stories of 2 may be of type C construction if it is a class 2 or 3 building or a mixture of these classes, and each sole occupancy unit has at least access to 2 exits or its own direct access. So we're not one of those, because we don't have that each sole occupancy unit doesn't have its own access. So back to the top, and this is the nature of the National Construction Code. It is very much like, it's all good except for this, and so you have to go down to that. So there's a lot of cross-referencing in the document. So back to type of construction required. So minimum type of fire resistant construction in accordance with table C1.1. So table C1.1 is this one just here. It's nice and close by. Type of construction required. So class 2 building. Think about the rise of stories. We aren't going to really tell me what rise of stories our building is that we're interested in. Well, one. Do I have any advances on one? Two. Sold. I don't think I'm going to get more than 2 out of it. Right. So we've got 2 stories. So we've got car park on the first story, on the second story. So rise in stories 2, and we are a class 2 building. So cross that over here. We are type B construction. Now, with our fire resistance levels that relate to our, so we know now that we're type B construction. I can't think off the top of my head exactly how I get to the fire resistance levels for that. So that's C1.1 fire resisting construction. Then we can scroll down and see 1.1, and we have type A, fire resisting construction. So if we're type A, we look in there, and this is our table relating to all of our elements and the fire resistance levels associated with that. Or we keep scrolling down, get to type B, fire resisting construction. And then we have our table there showing us our fire resistance levels for that. So the path taken is, we went first to section A, general requirements, classification of buildings and structures, to determine our building classification. From there, we followed a hyperlink to find out what type of construction we were. Then I scrolled down to section C, fire resistance, opened up specification C1.1, fire resisting construction, and we get to the point of finding our fire resistance levels of the various different elements of the building. So have a crack at that at home, finding those particular areas.